The topic of this video is graphing piecewise defined functions. Let's look at a problem. F of x equals 4 minus x if x is less than 0, 3 if x is equal to 0, x squared if x is greater than 0. Okay, so first let's discuss this problem holistically. This is a piecewise defined function consisting of 3 domain-restricted functions. So what we're going to do is we're going to take this and this and this, all 3 domain-restricted functions, and we're going to put them all on the same graph grid. But we're going to do this one at a time. Okay, so let's go through the steps that were presented in the learning workbook. So the first step says identify for each piece if it is an inequality or an equality. Inequalities are handled in steps 1 and 2. Equalities are dealt with in step 3. Well, we only have one equality, x equals 0. So this middle piece, f of x equals 3 if x equals 0, we'll deal with that later in step 3. Where we're going to turn our attention is to this inequality, which is line 1, and this inequality, which is line 3. What that tells us is that we need to create the entire graph of f of x equals 4 minus x so that we can cut it, and we need to create the entire graph of f of x equals x squared so we can cut it. All right, let's start with the top one. F of x equals 4 minus x. Well, we know that f of x is the same thing as y, and terms can be rewritten in any order you'd like as long as you keep the sign with the term. In this top line, the x is negative, so when we move the x term to the front, it retains its negative status. The 4 is positive, so when we move the 4 to the back, we have to put a plus sign in front of it. You might recognize this as a line in slope-intercept form. The slope is -1, which, if we'd like, we can write as -1 over 1. And the y-intercept is 4. So, creating a graph is very easy. All we have to do is plot the y-intercept of 4, which is right here, and then use the slope to rise and run to find other points on the line. Rise -1 means down 1. Run 1 means 1 to the right. So, from the intercept, we're going to go down 1 step and then 1 step to the right. And then down 1 step and 1 step to the right. And again, and again, and again, until we run out of room. Then we'll go back to the y-intercept and do the opposite. Instead of down 1, right 1, we'll go up 1, left 1. This will give us even more points on our line in the other direction. This is always a good idea because you never know which part of a piecewise defined function you're going to need to keep until you get really, really good at them. Okay, so clearly this is a line, so I'm going to use my straight edge. You must use a straight edge when drawing lines, line segments, or rays. So here comes my straight edge, and I'm going to draw this line. So this is the first full graph. This is the graph of f of x equals 4 minus x. But it has a domain restriction. X is less than 0. So what that means is I'm not going to keep the whole line. I'm only going to keep a piece. So how do I figure out which piece? After the word if, find the number, and that's where you're going to cut. So this is my scissor symbol. I find 0 on the x number line, and that is where I'm going to cut with my scissors. So I'm going to form a dashed vertical line at 0. This is going to cut my graph into a left side and a right side. Which side do I keep? Well, I keep the side where x is less than 0. Where is less than? That'd be to the left. So this is the part of the graph that I'm going to keep. Everything else to the right of the line is going to get discarded. It's going to get erased and thrown away. So I'm going to erase all of this. None of this will be part of my final picture. All right, the next step when graphing a piecewise defined function is to remember that we're still dealing with domain-restricted functions, and we have to put an open or closed dot where the curve meets the cut. What kind of dot is represented by less than 0? That would be an open dot. So where the blue curve meets the red cut is where we have to put our open dot. And the location of that open dot is coordinates 0, 4. All right, we've now got our first piece of our overall function. We're now going to turn our attention to the bottom piece. F of x equals x squared. Well, f of x equals x squared is the square function. I expect you to know from memory the points of the square function just as quickly as I know them. The x's will be -2 to 2, all the integers, and the y's will be 4, 1, 0, 1, 4. All right, plotting those points, we have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. This U-shape, or a parabola shape, is very familiar in algebra. It shows up a lot. So this is our third, because we're actually down here. This is our third piece of our piecewise-defined function. Just as we've done with the others, we now have to identify what part of the parabola to keep and what part to throw away. So we look after the word if for any numbers, and we see the number 0. So 0 on the x number line is where we're going to cut. We're going to cut vertically at 0. Then we have to decide which part do we keep and which part do we throw away. Well, this says x is greater than 0, so we keep the part to the right. Keep this over here. That means everything to the left of the red dashed line is not going to be part of our final picture. And as the last step in creating the graph of a domain-restricted function, we have to put a special dot where the curve meets the cut. The dot we'll use this time is an open dot because of this inequality symbol. So we put an open dot where the blue curve meets the red cut, which is right here at the origin. So the location of that open dot is 0, 0. All right, we're ready now to begin creating our final graph for this particular problem. We just have to take the blue part of this graph, the blue part of this graph, and put them together on the same graph grid. And then we'll go back and deal with the middle piece of our piecewise-defined function. So we know that we have an open dot at coordinates 0, 4, and we know that we have a line with a slope of -1 coming down towards that particular dot. We know that we have an open dot at 0, 0, and we know that we have a parabola coming up and away that goes through coordinates 1, 1, and 4, 2. 1, 1, and 4, 2. Now all we have to do is the middle piece, which is the easiest. The middle piece says f of x equals 3 if x equals 0. F of x equals 3 if x equals 0. Well, remember that f of x is the same thing as y. So what that's really telling you is x equals 0, y equals 3. So make an ordered pair out of it. And you get the ordered pair 0, 3. This is a closed dot because it uses the equal sign, and it goes at coordinates 0, 3. And with that, we have created our graph of our piecewise-defined function. In our next video, we'll look more at this problem, and we'll talk about domain and range, and whether this graph is continuous or not.